Good evening, ladies and gentlemen. My name is Abdurrahman Ali, and today, inshallah, I'm going to solve question number 4 in chapter 4 for fluid power fundamentals. Let's see the question now. A spherical shell made of a material with a density of 1600 kilogram per cubic meter is placed in water. If the inner and outer radii of the shell are R1 equal 5 centimeter, R2 equal 6 centimeter. Determine the percentage of the shell's total volume that would be submerged. So first of all, I have to write the given things. So given. First of all, we have rho. It's already given 1600 kilogram per cubic meter, and we have R1, which is 5 centimeter. We have R2, which is 6 centimeter, and according to the question, he wants to know the volume that submerged. So V submerged, it is unknown. So how can we solve this question? First of all, we have to draw the spherical shape. We know we have two radii. So we have the first circle. This is the inner shell, and we have an outer shell. So the inner shell is 5 centimeter and the outer shell is 6 centimeter. So what he wants, so we know that this ball is submerged on the water. So what he needs the volume of the submerged one. So V here is unknown. And later on, we know how to find this one by analyzing the forces that acting upon this object. We know we have the buoyancy force, which is acting open up, and we have the weight of the object itself acting downward. So how to solve this one? First of all, we need to find the total volume of this object from the inner and outer shell. Then we can find the mass of this object by finding the volume. So let's see now. First of all, I have to get the volume of this shape. So V total equal. So the equation for that one is 4 over 3 times pi. So we know we are having inner shell and outer shell. So R outer minus R inner. Both are cubed. It's supposed to be cubed because it's a circular one. So it is 4 over 3 pi times 6 times 10 to the power minus 2, all cubed, minus 5 times 10 to the power minus 2, all cubed. So after a little bit calculation, we know V total is equal to 3.8 times 10 to the power minus 4 cubic meter. So after we found the V total, now we can find the mass. So the mass equation is rho times V. So we have rho, which is 1600, and we get the volume now, which is 3.8 times 10 to the power minus 4. So mass is equal to 0.6096 kilogram. After we find the what we call the mass, now we can go and find the what we call it, the volume or the submerged volume from the forces that acting upon this ball or the spherical shape. So let's say summation of all forces on the y-axis. So we know the buoyancy force, it's in positive because it's upward, and we know the weight of the object is downward, so it is going to be negative. So we know FB is equal to rho of the seawater times V, which is submerged, times gravity minus, we know W, okay, is equal to, now W is equal to 0 point, which is W equal, mass time gravity, okay, which is the mass we do have because we got it at 0.6096 times gravity equal 0. We know gravity, where the gravity is going to go, so we need the V submerged, we don't know it, so V sub is going to be 0.6096 over 1000, because it's the density. So we're gonna get this value, 6.096 times 10 to the power minus 4 cubic meter. So we know the V submerged is equal to this one, so after we find the V submerged, okay, he wants the percentage of how many percent of this one will be down or under the sea. So we can say the percentage of that one, of the V submerged, is 6.096 times 10 to the power minus 4. This one is the V submerged over 4/3 from the total of the submerged, to the power 3. Okay, times 100. So, V total we get now V total, okay, or V submerged over the V submerged, or the total of that one, times 100, we're gonna get 67.34% submerged underwater. And that's it. Thank you guys for watching. Hope to see you inshallah soon.